Hello, so let's look at this question together. This is year 2011 and question number 2. So first begin, why don't you take a little bit of time to read this question. We have time here, degree Celsius given, and talks about how pot of tea cools down as the time goes. Now, to answer A. Use the data in the table, approximate the rate of, you see the word rate, in this case, this word implies the rate of change. In other words, we are looking at h prime. At time t is 3.5, but as you can see, we don't have that value. How are we going to do it? We can do this one by using the mean value theorem. So we can say h prime of 3.5 can be approximated by the two values around it between when t equals 2 and t equals 5. So h of 5 minus h of 2 divided by 5 minus 2. Now this basically means h of 5 was 52 minus h of 2 was 60 over 3. So we end up getting negative 8 over 3. And that becomes our answer. So if you wanted to put a unit behind it, then it would have been degrees Celsius over minute. All right, let us try to answer B. Using the correct unit, so in this case, we definitely have to put down the units, otherwise we may lose a point. And we need to explain the meaning of this expression in the context of the problem. So in this case, this basically represents the average value formula. Now, but in order for us to approximate this area using the trapezoidal rule, given the 4 subintervals, that means this becomes first trapezoid, this becomes second, third, and fourth. So let us try to approximate that first using the trapezoidal rule. From 0 through 10 of h of t dt. Now, if you remember, the formula of the area of a trapezoid will be 1/2 base times height. So we have 1/2. And as you can see, the interval is not constant. So therefore, we cannot just put everything together. 1/2. Let's look at the first trapezoid. Base 1 becomes 66 and base 2 becomes 60. So 66 plus 60 times by height, which is the difference between those two, which is equal to 2 times 1/2. But since 1/2 is common, so we just factor that out. Second trapezoid, 60 plus 52 times the interval, which is equal to 3. Third, 52 plus 44 times the interval, which is equal to 4. The next, which will be equal to 44 plus 43. And then interval is equal to 1. Now, if you have to evaluate this one or calculate this, let us see what we end up getting. So I'm going to clear. So 1/2 or 0.5 times. We end up getting 126 times 2 plus here 112 times 3, and then here 96 times 4, and at the end we just have 87 plus 87 times 1 if we wanted to include 1. Then we end up getting 529.5. So 529.5. Now, so therefore, if you divide that by 10, we'll end up getting the expression 1/10 from 0 through 10 for h of t. Therefore, dt is equal to 52 0.95. Now, the unit is simply the degrees Celsius. Now, the meaning behind it will be it is average temperature of the pot over T goes from 0 to 10. That becomes our answer. All right, let us try to answer C together. C is to evaluate this one using the correct unit. Now, in this case, what we like to do is this. We like to look at fundamental theorem of calculus. Based upon fundamental theorem of calculus, I call it fundamental theorem of calculus, FTC. We end up getting f of 10, h of 10 minus h of 0. But h of 10 was 44, or 43 minus 66, which will be equal to negative 23 degrees Celsius. Now, explain the meaning. This will be difference of temperature between T is equal to 10 and T is equal to 0. Now, let us try to answer D. At time T equals 0, a biscuit with temperature 100 degrees Celsius was removed from an oven, and then we realized that B prime of T, which represents the change of the temperature in the biscuit, is given in this way. Now, we need to see how much cooler are the biscuits than the tea. So first, what we like to do is put that expression right over here into our calculator. So I'm just going to clear these. So negative 13.84 times e to d negative 0.173 x. All right. Now, so knowing that, basically what we are about to do is this. For d, if you integrate from 0 to 10 for b prime of t, we'll end up getting b of 10, which is what we're looking for, minus b of 0, which we know already from the question. It was 100 degrees Celsius. Now, then what we end up getting is this. From here, if you have to graph it, we'll get us some sort of an expression here. And second, trace, which will give us this menu, go to number 7. And lower limit becomes 0. And upper limit becomes 10. Then as you can see, that becomes our answer. Now, by putting all these things together into the equation, then we'll end up getting negative 65.817 is equal to temperature of the biscuit after 10 minutes minus 100. Now, by adding 100 to both sides, then B of 10 will be equal to 34.2. About 34.2 degrees Celsius. All right, so we realize that this one is much cooler than the pot. How much cooler? We can simply subtract between these two. So we end up getting 43 minus 34.2, which will be equal to 8.8 degrees Celsius cooler. Thank you.